Welcome to Newton's second law video by Dante and Connor. Essentially, Newton's second law is simple as this. Force equals mass times acceleration, or F equals ma, where newtons equals kilograms times meters per second squared. Now, with the basics already accomplished, let's go into a quick example. Example 1. Consider a race car. Sally, the speed racer, is driving her car with a mass of 500 kilometers and is accelerating at 10.00 meters per second squared east. Then what force is Sally's race car exerting? Well, first, we always like to draw a diagram like right here and label the mass because that was a given, and label the acceleration because that too was given. We then like to put in a reference point and the direction of the acceleration so that we can also know in what direction the force is going. So this equation, we simply sub in m and a into the equation F equals ma. So if m equals 500.0 kilograms multiplied by 10.00 meters per second squared, the answer is 5,000 newtons. Yet for significant figures, we use scientific notation and you go to 5.00 times 10 to the 3 newtons east. Now, let's actually consider and look at what Newton himself would have used when he was using his own second law. Newton would have looked at momentum and impulse instead of using acceleration in the equation F equals ma. In just a second, I'll show you how Newton would have derived his momentum and impulse part of his equation, and it is very simple. So if, and actually that should be since J, which is impulse, equals delta P, momentum, a change in momentum, then P2 minus P1 equals mv2 minus mv1. So what Newton would have used is F equals ma, but instead of acceleration, v2 minus v1 over delta t would have been subbed in. Then expanding, it would have been v1 over t, which basically means it was delta p over delta t, therefore having j over delta t, which is impulse over delta t. So Newton actually would have looked at impulse over time, so the change in momentum over time. Simply put, F equals ma, and forces can be seen all around you every day in the world. We look at forces from the moment we get up to the moment we go to sleep. A couple examples. From this little ant walking down the road to this person riding a bicycle. Even to this sailboat on the water. Newton's second law is all around us. Anyway, thank you for watching this video, and I hope you now understand all about Newton's second law and F equals ma. And now that you get Newton's second law, go out and truly see all the forces of the world.